Today we are talking about Bluetti's RV5 Power System. We're going to be talking about some of the things other people didn't cover, like maybe solar charging, also 120 volt and 240 volt generator charging. That way, if you happen to have a favorite generator that's 120 volts, or maybe you want to use a 240 volt supply, we're going to cover a little bit of that information as well. We're also going to cover some of the other features such as 2 wires start generator charging, and hopefully by the end of this video you'll know if this is a good option for you. Now, my name is Johnny, and if you guys have followed me before, you'll know that I was running EcoFlow's power kit inside of my RV for over a year. This is a great RV power system except for one major fault, and that is honestly the price. They have priced 90% of the people out of their market because it's so expensive. While being a good kit, they're missing 90% of the market because there are so many other DIY solutions out there, or honestly, you could throw in any type of power station into your RV if you wanted something for a quick solution. But if you're looking for something a little bit more permanent with more power and some more options, then this is probably something you may want to look into. Now, I've said this once and I'll say it again, when EcoFlow came out with their power kit, you will see other companies starting to follow suit. Now, this is where Bluetti took note because there is a hole in this market, and one of the things was, again, the price of the EcoFlow unit. It was absolutely crazy because it leaves you with so many other options. So now this comes in at a real respectable price, and you can use just the inverter alone if you want, or you can use the batteries alone if you want. So first, let's go over some of the specs of this unit. We'll start with the RV5 Power Hub. This is basically 5 units in one because it does have 2 solar charge controllers in it. It also has a DC converter, 48 volt to 12 volt. It can also do 24 volts out, which this is actually a huge benefit because there are really no inverters out there that offer this feature, and this is huge for the RV market. It also has a 5,000 watt pure sine wave inverter, and it also allows charging at 120 volts or a 240 volt source. Now, when it comes to the RV5 battery, this is a 51.2 volt or a 48 volt system battery that is 100 amp hours that provides 5,120 watt hours. Now, this whole system is also capable of being used in, say, an off-grid cabin, and this can even be used in a yacht, or if you're looking for something for your marine application, this is acceptable to use. Now, one of the cool things about this unit is that you can stack 8 of these batteries for incredible expansion. That's about 41,000 watt hours of energy. But by using Bluetti's eDock, this allows you to stack even more of these batteries, which brings you out to 123 kilowatt hours of energy. So that would be 24 batteries that you can use with this system, that's a lot of energy and more than most people are going to need. Now, when it does come to installing this, honestly, it's not really that hard. This is much easier than, say, a Victron system where there are a lot of conductor wires and more and a lot of different pieces. They provide you a kit that shows you how to mount this with a mounting template. They also give you an instruction guide, which some people seem to make it a little bit more difficult than it is, but honestly, if you just follow the steps and even maybe get a buddy, you can honestly have this installed in one day. It's not really that hard. Now, this isn't as easy to install as EcoFlow's power kit, but again, you're looking at something that is 3 times the cost of what this is, and honestly, this gives you something to really get your hands a little bit dirty, and it lets you learn a lot about how to connect systems, because in that chart, everything is labeled. If you look at the conductors, your positive and your negative cable, it really tells you where everything needs to go. You simply hook up your positive and your negative to the RV5. You're also going to just hook up your AC wires, which they already tell you where all this stuff goes. Again, it's not really that hard. It's just following along in the instructions step by step. And then after a few hours, this is ready to go. It's turned on. And now your RV connection might be a little bit different. That's something you'll have to figure out. But again, they provide you with all the necessary cabling. They have extensions. They also have battery parallel cables. So if you need the short ones, if you want to stack the batteries, they have short cables for that. They also have longer cables if you want to put the batteries side by side. They provide disconnects for the battery itself. They also have a disconnect if you wanted to hook this up to, say, a car charging system, because this does have alternator charging capability. So when it does come to installing this, this is definitely much simpler than than say doing a whole Victron system, which those can get really complicated depending on how extravagant you want to get and all the extra pieces, because remember, this is 5 pieces all in one unit. Okay, so now let's go through some of the testing. We'll get that out of the way real quick because some of it is starting to get real monotonous when it comes to testing inverters. It's really just looking to see if it has a pure sine wave, which this one does. I ended up testing this at over its 5,000 watt rated limit. And as you can see here, the pure sine wave looks good. And also I tested total harmonic distortion, which you can see here, it is showing about 1.3 to 1.4 under that full load. And most of the industry standard now is 5% or less, or even 3% or less, and this had no problem passing. Now, one of the things I did want to check was also AC idle consumption, because when you turn on your AC inverter, it starts to use power immediately, but because of my particular RV, it's going to turn on the transfer switch, transfer power to the RV, and I also have a few things in there that will draw a few more watts. So this gives me an idea of how much power is being drawn. But you can see here that it's drawing about 26 to 28 watts, give or take, as it just sits here at idle doing nothing. Which honestly, that's not bad considering some other inverters, like if you look at an XP6000 EG4 inverter, that also uses around 35 to 40 watts when you turn on the AC inverter. So this is actually pretty efficient. Now, one of the other tests I did do was an AC capacity test. This is basically charging the battery to 100%, turning on the AC inverter, and then what I did is a 0.2 C rate, or roughly close. That is just over 1,000 watts. And what that would be is like simulating me running the front air conditioner in my RV, because that will normally draw between about 1,000 to 1,100 watts, give or take, on the temperature in the day. Now, after running this test, it was actually a little bit disappointing, as I was only able to get 83 amp hours out of this battery, which honestly is not very good. There's a lot of other tests that when you do this, the same type of test, you can normally get the full 100 or maybe even a little bit more than what's stated. So that means I was able to get about 4,350 watt hours of energy out of this battery, because I only tested one. I didn't do both, just one at a time. So that means I was only able to get 85% of the energy out of this battery. And when you go to the AC side and you look at this meter here, that means I'm actually losing even more after the conversion out of this. So another 10% means I was only able to get about 3,875 watt hours of energy to provide to the AC unit. So that means that this battery would run the air conditioner roughly 3.5 hours, give or take. But one of the interesting things is if you look at the voltage where it's at, it says 49.3 volts roughly. And if you look at this chart for 48 volt charging, it actually shows that I should still have about 10, maybe 12% left of energy inside that battery, and 40% would definitely be dead, and a little bit over that you might have a couple percent. So it seems Bluetti is actually holding back some of the energy, which some of the other companies are starting to do this now. They won't let you discharge all the way to absolute zero, because in the power station world, if you were to do that and say let it sit for 3, 4, 5 days because you weren't able to charge it for some reason, maybe you're not around, you could actually brick that unit. That means if one cell is a little bit too low and the BMS reads that when you start to charge it, it will brick the unit and say there's a fault, and now all of a sudden that power station is no good. It won't let you charge it. Now that might be something Bluetti is doing here, is they're holding back some of the energy so you can't get to complete zero, and I am running the latest firmware in both of these items, so maybe that's something they'll change later and let you get down to say 5%, who knows? You shouldn't always go all the way to zero anyway. I usually have my cutoff at about 5% anyway, so if maybe they do an update, who knows? Okay, so now we're going to talk about 120 volt generator charging, because this unit can charge up to 5,000 watts with 120 volts or 240 volts, but there is a difference. Now, if you start charging at 250 volts on this, it's actually not going to work for pass-through. That means it shuts off the AC inverter and you can only charge it. So if you're wanting to do 240 volt charging, in the app it actually says 240 volt EV mode, which I'm not really sure about the EV, but I guess you could hook up an adapter. But again, just know that you're not going to have the use of the AC inverter. So 120 volt charging is really what you're going to be looking at wanting to do. Now, one thing that's nice about charging at 120 volts, say using a small generator, is that the generator isn't going to be affected by the loads. So let's say you have a load of around 2,500 to 3,000 watts. You can still use your favorite little generator and charge at a lower rate. So you can charge at say 1,100 watts, 1,500 watts, 1,800 watts. It doesn't matter, because you can control that within the app. And so now you don't have to worry about overloading your small generator. And if you're only running, say, that high load for a couple minutes, maybe the microwave is on and you're cooking something, the generator isn't going to be affected by that overload and trip. So that is actually one of the features I like about this. I can run a consistent, steady 1600 watts in coming from the generator. And again, I don't have to worry about it overloading and tripping and then going outside and resetting it. So just remember, if you are charging with 240 volts, again, you don't get the use of the AC inverter. That would just be for quick charging only. Okay, something else nobody really talked about was the back of the E-pad. It has all these connection points, and if you notice, it has a common and an NC1. This actually is the same type of feature that you find on bigger inverters, and this allows for 2-wire start generators. So as you can see here, I have this GenMax model. This is a 2-wire start generator, and this is something I showed by hooking up a EG4 inverter also with the ChargeVerter from EG4, because it can work with both of those. But Bluetti gave you all these options to add tank sensors and all these other things onto the back of the E-pad, but they also gave the option for a 2-wire start generator, which is totally cool. So if you have a unit that has an onboard generator, you can actually operate it with that, or you can just add one later. It all depends on what you want to do. But here's one of the things I found is that even though I tried to change certain settings to say generator or relay or, you know, automatic start or turn on the relay either to common or open and more, I couldn't get it to work. Those functions are actually not available yet, so they have to provide the update so I can actually use it. So that was kind of a bummer. After playing with it for a while, I found that, and this is the same thing that happened with EcoFlow, not everything was available yet when this came out. So it won't be long, I'm sure, until they push again another firmware update, and then that'll allow me to use that 2-wire start function. But again, it's there, totally cool. It's just not available for me to test and use yet. So anyway, and maybe you'll be able to set up a voltage thing too. That way it automatically starts. You set up your low voltage or state of charge percentage, and then it'll start the generator automatically at, say, 20%, because there were times you could also set it up to start and stop. It just, again, it's not available. Okay, let's talk about the DC out function, because this is actually something that is great for RVers, van builds, and more, because you can run this over to their own distribution panel. But RVs always have their own distribution panel in it anyway that has all of your AC and all your DC circuits in it. So if you're going to be using this in an RV such as mine, that's something you don't need to buy. Now the DC out on this does offer 12 volt and also 24 volt. For me, obviously, I'll be at 12 volt, but this means I can run the wires directly to the RV and I can bypass the battery, so that technically could save you some weight, it can save you some room, and it provides 100 amps, which is about 1360 watts. So technically this means, again, you don't need the batteries. Now for me, what I do is I actually still maintain my battery, because this allows me to not have this system on, so my RV will work as normal. I still have my landing gear that will still work without having to turn this on, along with all the lights and everything else that your RV would normally function as. So this kind of gives you a little bit of redundancy by still keeping a small 12 volt battery inside the RV. But one of the cool things again is that when you turn the DC on, this is actually going to start charging that 12 volt battery. Now if it is a lithium battery, it's going to charge it to about 95%, because this only puts out 13.6 volts. So it'll then match it over to that battery, which means it's not quite 100% charged, but again, you don't really need to charge an LFP battery to 100%. 95 is fine. There's not a lot of inverters that have a DC out. They're only AC. So this is why this inverter is actually pretty nice. It just has one kind of big problem, which we're going to talk about now. And so now we talk about kind of the downfall of this unit, which is the solar charging, because they're trying to meet RV Industry Association standards, which is that Rivia thing that you will see on the RV. And by doing that, what they did is they put 2 solar charge controllers in here, which is great. 2 is at least the minimum. 3 would have been amazing. But because of the solar input voltage, which is at 12 volts to 50 volts, that makes it extremely hard to build certain arrays into this, especially if you want to be able to take advantage of the full 1800 watts per input. That's 3600 watts. And the reason they did it this way is because to meet that certification, it has to be under 60 volts, or at least 60 volts and under, which I don't know why they didn't do 60. Now, one thing they did do is increase the amps up to 50, which 50 amps is a lot of power, and that creates a lot of heat, and you can melt MC4 connectors and more. That's why most everything is rated at 30 amps and under. So if you wanted to run 50 amp MC4 connectors, you can. You You just have to go searching for it. That's only industrial stuff. You're not going to find that in the normal recreational market. That means you have to run bigger wires, you have to get the bigger connectors and the bigger pins, all that stuff. So running 50 amps is like, okay, great, but it's not really usable. So that means now you can't take advantage of that full power. So not that that's a complete deal breaker, it just makes it a lot tougher, because I built a brand new solar system on top of my RV, and I actually built it so I could test some other units, and I put it under 60 volts, but my open circuit voltage is right at 54. And this lets me test several different types of power stations and more, but because this is at 50, it has a hard stop at 50. I plugged it in anyway just to see. It might have blown up the controllers, but it didn't. But it definitely didn't allow charging as the red light did come on. I even did it on a cloudy day where my voltage was basically at minimum. It was like 52 volts, and it was definitely no. And again, trying to meet that certification, that's like going the same way that like Go Power does. If you've ever seen these type of controllers, guess what the voltage is? It's 12 to 50 volts at a higher amp. So now instead of being able to use a new solar array that I just installed on my RV, which I used all Calisun 200 watt bifacial solar panels, which these solar panels performed excellent, and I actually tested them against several other different solar panels, and these were the best ones that I could find at 200 watts. But right now, the thing I have charging this is actually my solar fence, because it's actually under 50 volts at a little bit higher amps, and so it's providing somewhere between 250 and 450 watts depending on the conditions during the day. Now this isn't a deal breaker for this, because technically what you could just use is a couple of separate MPPT solar charge controllers like this Victron one. You don't need one with maybe this specification, but depending on your solar array build, you just want to make sure that you get one with at least a high enough voltage and something that can handle enough amps for your build. I would probably use some other batteries for my specific build, which you'll have to excuse me here. This is not a completed setup at all. I'm actually going to be changing this whole thing again, because as I was kind of laying this down, I didn't really like what I was doing, and then I started thinking about the other type of build I'm going to do, which you guys will have to see, because I will be doing a third-party battery setup with this inverter, and then I'll show you how I use these as well, because I do like this inverter. The only thing is I don't like the solar input, so I'll use a couple of these. But what I will do is I'll use these solar charge controllers here for when I am out and about and I need to put down some portable solar panels, because depending on the time of year when the sun is lower in the sky in the fall, maybe the spring, having a portable setup is excellent. So this allows me to just put some extensions here, and then I can run them out to some solar panels, so it gives me an extra option. So that I found beneficial, and I can still use them, but I'll just use them for the portable panels that I'll put out on the ground when I am at certain locations. Okay, so now that we're done talking about all this, let's go over the cons. We'll go over pros and also some things that I would also like as well, not to mention pricing of this stuff. But con number one is really the battery not being able to put out more than 85% of its capacity. So maybe a firmware update will allow you to go down farther, say maybe 5%. Now these are a little bit more expensive than third-party batteries, but that's also because you're buying it as a kit, you're buying the Bluetti name, and not to mention this just came out. So anything that's brand new is obviously going to be more expensive, but you will see discounts, you'll see price drops, which you can check that information below for current pricing. And one of the other things about the battery is that the footprint is a little bit larger than, say again, some of the other third-party batteries. But as far as weight goes, this is pretty much standard weight, about 102, 103 pounds for a 100 amp hour 48 volt battery. And con number two would be the solar charging with the low solar input voltage. Again, why didn't they at least do 60 volts? That would have given you a little bit more room to work with. Now again, I get it, they're trying to go with that certification, but again, it just makes it a lot harder to build your solar arrays around that. So I don't like it, but I get why they're doing it. Now also when it comes to the ePad, the ePad is pretty nice, but as far as its latency when you're trying to scroll through the screen and everything, it's a little bit slow. Same thing with the app. It's a little bit slow when it comes to updates. Now this is something I assume they'll just push firmware updates that'll make it run smoother, because again, this is brand new. And that was the same thing with EcoFlow. When it first came out, they had all kinds of bugs they had to deal with. And after about 3 months of it being on the market, they pushed a couple of updates and it worked much better. So I assume Bluetti will do the same thing. They'll get some user feedback, start seeing what's going on, start pushing updates, and then the whole system will just start running better. And again, we may be able to see more usable power out of the batteries. But one other thing with the ePad though is that I wouldn't mind something that was maybe a little bit more of a flush mount, but that's because again, You have all those communication cables that can plug into the back, so you do have to have some room. Okay, let's talk about pros, and really one of the big things is the cost, especially when it comes to the inverter. At the time of this video, it's $1,299. I want you to take a look at 48-volt inverters that have this many features in it that is for an RV. You're not going to find any, especially when it has a DC out. That is something you won't find anywhere. The only one that's available is EcoFlow, but if you buy that, you have to buy everything. Again, this can be used by itself, so I think the inverter is actually really nice. It's efficient, it's actually quiet, it's not very loud. When I did dB testing, when I was running a moderate load, the fans on this didn't do a bad job. As you can see here, the dB levels were in the low 60s, and here's what it sounds like under that medium load. So overall, this is definitely acceptable as far as an inverter goes. But even again, when it comes to pricing and buying this as a combo, let's just say you bought a 15 kilowatt kit from EcoFlow, you're still looking at around like 14 or 15 grand. It is crazy. Now I know they'll have sales too, but you could buy a 15 kilowatt kit on this for less than 10. It's actually cheaper than that. This inverter is only $12.99. If you buy one battery, it's like $27.99 for the kit. Add another battery plus the E-pad, you're at $5,000 or less, and that's not even including discounts, which again, you can check that below, but that's a pretty darn good price. And again, it just came out, so we know what happens when things just come out. They're always at their most expensive. Okay, let's talk about now what I want. Hopefully Bluetti is listening, or I don't care if it's another company, but what I would do is I would take this inverter and make an off-grid version only. No Rivia certificates and none of that junk. Give me 3 solar inputs at 30 volts to 150 volts, and it could be 15 or 20 amps. I don't care. I could work with either one of those, and maybe make one of them a little bit higher amperage for alternator charging. But this gives me enough to put 2 large solar array inputs up on the roof of an RV or whatever. Plus I have the third one again for putting out portable solar panels when I need it, depending on the time of year, location, and more. Other than that, keep the rest of it the same. You already have the DC out. That is super helpful and something we need. The 120 volt charging is great. You don't really need 240 volt charging, especially if you can go to 5,000 watts. That's perfectly fine. I guess the only other thing I could think of is maybe shrink it down 10% if you could. If it could be a pinch smaller and you could do 3 solar inputs at, like I said, and just do an off-grid version only, especially at the same price, I guarantee you will outsell everybody in the 48 volt market when it comes to an inverter, because nobody has the DC out function and nobody has 3 solar inputs that are low voltage. If you look at all the other companies, all of them start at least 80 volts. Actually, they start at 120. So this means you need a much higher solar array to be able to just to turn it on. That means you need your solar input voltage actually a lot higher just for it to run efficiently. That means you would want, if it's a 120 volt turn on, you need at least 160 to 180 minimum, because it's going to be 120 to probably 450 volts. So 30 to 150 is all you need. You will outsell everybody in the RV market. Let me know what your guys' thoughts are on my idea, and if that was something that you would buy. And what do you guys think about the new RV5 power system the Bluetti just came out with? I think it's a good unit that could just use a couple small updates, but you can check discounts and information down below. I hope you liked the video, and I hope to see you in another one.